A couple things with fractions, like I keep saying over and over again. Sometimes use just the denominator, okay? Which in this case, that's partially true. And another thing that you should be paying attention to, like if you're unsure about what to do, is if there's a big plus in the numerator, you're allowed to break this apart into two separate fractions. And that's what we need to do here, actually, okay? Because I want to let u be the denominator here, 3x plus 1, but then du is just 3, okay? And we got the dumb x up top. So remember yesterday we talked about if you have that extra x, you're going to have to solve for x in terms of u. So we got to do that in one of them, but because of this pluses here, we're allowed to kind of break that apart and do each one separately is what we're going to do. So this is going to become the integral of x over 3x plus 1 dx. I'm going to make it two different integrals plus, was it 2?
Yeah.
2 over 3x plus 1, right? Okay. And this one over here, we're going to let u be the denominator. That's a terrible 3. 3x plus 1. And du then is just 3 dx. Cool? And guys, so I don't know if this is obvious for you yet or not. Like the key to this whole u sub, is that you have to get du. Okay? Everything else just kind of falls into place a little bit. But if you can't get du to happen, then you can't do the substitution you're trying to do. All right? There's no like right or wrong or anything like that. Just if you can't get du, then it's not going to work. So you got to try something different. In this case, I can get du. I need 3 dx. I'm only missing a 3. Great. Put a 3 in there. If you put a 3 next to dx, then you got to put a 1/3 out front. Is that okay? And as a matter of fact, I'm going to do the same exact thing in the other integral. I'm going to let u be 3x plus 1. Right? There it is right there. And then I need a 3 on this dx, which means I need to put a 1/3 out of this integral. So technically, like I'd actually write this over here. This is the same thing. So if you split up an integral like this, u doesn't have to be the same thing in both of them. In this case, it is. But that doesn't always have to be the case. All right? Also, like one of them might not even need a u sub, but in this case, it makes sense to do a u sub here. So this first integral is going to become, if we plug all this crap in, 1/3 the integral. You have u in the denominator there, and we still have that x up top, and then we have a du over here. Is everybody okay with that? And that right there, that's our red flag. Oh my God, there's an extra x. I need to go back and do that like harder substitution thing again. All right? But in my second integral, we're going to have 1/3 the integral of just 1 over u du. Or was it 2 over u?
2.
2 over u. Okay, so we can actually, I'd probably just put the 2 out front here.
But would it be 1/6? So the 2's on the top.
No, so look, that 2 was already there, right? Mm-hmm. So we're not canceling out the 2, we're just moving it out front.
Okay.
I had to cancel out the 3 because there was no 3 there,
Okay.
and I put a 3 in. So I have to cancel out what I put in. All right? So the right-hand integral is easy to do, right? We can just do that one pretty easily. Something that I see a lot of kids do is like they'll leave it as one big integral or something, and then they'll do part of the integral but not the other part. Okay? If you're going to leave it as one big integral, you got to do it all together. Right? You don't want to like have half integrated thing or something, like some kind of monstrosity where it's half integrated and half not integrated or something. Okay? So either split it apart or do the whole thing in one step. But either way, in this case, we got to plug back in what x is. So I'm going back up here to what u is, and I'm going to solve for x. And it turns out x happens to be 1/3 u minus 1. Okay? And then all we're going to do, hello sir, is plug that in for x. So we get 1/3 the integral of 1/3 u minus 1 all over u du. And this one we can just integrate and get 2/3 ln of u plus c. Cool? And keep in mind, like we've integrated that already. We don't need to integrate ln again. We already did the integral. Like du is part of du's job is to let you know that's when the integral stops. Okay? It's really like a set of parentheses. What's up, man?
Did you say that to like write it like that, where it's half and half?
Well, because I got the du there and everything, like this part here is still an integral. This part here is just something added at the end. So that's okay. But sometimes kids won't have that du there and they got half integrated, then integrate twice or something. They just end up messing themselves up. Okay? So you're right. I guess really the best way to do this is not to integrate either of them until you're ready to do both of them, I guess, all in one step. Cool, because then you end up confusing yourself a little bit, but I just broke that rule, I guess. All right? And this one over here, if you follow with me here, that 1/3, I'm just going to move that out front. That makes it a 1/9. And then this integral becomes the integral of 1 minus u to the negative 1.
Why is it using the negative 1?
Okay, well, because we're doing u divided into u and u divided into 1. So u divided by u is 1, and 1 divided by u is just u to negative 1. All right? So in the end, we get 1/9 u minus the ln of u, right? Plus 2/3 the ln of u. And you only need, even though we did 2 integrals there, like there's just 1 plus c. Like we just have one number at the end. Okay?
How'd you get u by this ln of u?
We're integrating this right here. Integral of 1 is u. Integral of u to the negative 1 is ln of u.
The integral of 1 is u?
Yeah. What do you get when you drive u?
Oh.
1. Okay? They just plug back in what u was. And actually, this doesn't always happen either. We can actually combine these things here. We have minus ln u plus 2/3, or ln u, whatever, plus 2/3 ln u. So that's really 1/9. And u is what? 3x plus 1? So I plugged in there. And minus 1 ln plus 2/3 ln's is minus 1/3 ln of 3x plus 1 plus c. Whew! Okay?
You don't distribute the 9. Your 1/9. You don't distribute.
Oh, you can, yeah. So, yeah, we can distribute the 1/9. So, again, if this open-ended, free response, whatever kind of question, totally fine. What just happened? Totally fine answer. Okay? If it's multiple choice, you might not see it just like this. They might distribute that 1/9, which is 1/3 x plus 1/9. And they might, just for fun, distribute that 1/3 here and make it a cubed root, okay? Cool? Okay.
For like